So last week we did something about definite integrals. So this is the second type of integrals. The first one was indefinite integrals, where we have expressions rather than okay constants or numbers as the answer. Okay, so that's the main difference between indefinite and definite integrals. Now, so again, if you have limits, oh now indefinite integrals, we have now this thing called limits. Okay, so when you get the integral or the antiderivative of a function from a to b, so you just subtract the integral of b minus the integral of a. So just that. Okay. So again, so let's say we have the antiderivative of 8 from 2 to 5. Okay. So we basically get the integral of this. So we have 8x, and then we substitute 5 and 2. Okay. So the integral or the antiderivative of 5 first minus the antiderivative of 2. So that's how you get 24. Okay. So same goes with this. So the antiderivative of 3x from 2 to 5. And then so you get the antiderivative first of 3x. So you got 3x squared over 2 from 2 to 5. So we start with the upper limit. Okay, so we just substitute in 5 here minus the same term. We substitute 2, and then so we got 63 over 2, or 31.5. Okay, now what if we have an expression instead of just a term? Okay, so here we now have an expression. So we have 8x minus 4. So let's find the antiderivative of 8x minus 4 from -1 to 1. So basically, it's the same topic, or it's the same way. Okay, so we get the antiderivative of each like this. Okay, so our answer here. So the antiderivative of 8x minus 4 is 4x squared minus 4x. All right, and then starting from -1 until 1. Okay, so this is the upper limit. So the expression, and then we substitute in 1, okay, being our upper limit, minus the same expression, now plugging in -1 for our lower limit. So simplifying this, our answer is simply -8. Okay, one more before we go to our topics or our questions for today. Now let's have another example. So let's find the antiderivative of 3x squared minus 2x plus 5 from -1 to 0. Okay, so first we get the antiderivative of this. So this is the process here. So again, the answer is x cubed minus x squared plus 5x, and then we get the upper limit and the lower limit. Okay, so this one is for the upper limit. So same expression, we just plug in 0. Okay, being our upper limit, minus same expression, but then now we plug -1 for our lower limit. So simplifying this, our answer here is simply +7. Okay, so now let's begin with another set of examples. Okay, now let's have fractions. Okay, okay, all right. So let's have letter D first before we have one fraction. Okay, so letter D here. So we find the antiderivative of the root of 2x plus 1 from 0 to 4. So we basically first rewrite this and get the integral of this. Okay, so having this, so how do we get the integral of this? When you have an expression and then you have an index outside the expression. Okay, so we basically plus 1 this again, so that's how we get 3 over 2, and then we just rewrite 2x plus 1, and then what happens with the denominator? So if this is 3 over 2, this is 3 over 2. But then, since this is an expression, we consider the coefficient, which is 2. Okay, so simplifying this, we get 3. Okay, We cross that out, and then, so that's it. So this is the integral of this question. And then, so we now find the limit from 0 to 4. Okay, so same expression, we just plug in 4 being our upper limit, and then minus for the lower limit, we plug in 0. Okay, and simplifying this, so we'll get 9 minus 1/3. So therefore, your answer is 26 over 3. And that's for letter B. Now, let's have another one. Now, let's have fractions. Now this is example letter E. Okay, so let's have this question right here. So let's find the antiderivative of 2x plus 1 over root of x from 1 to 4. Okay, so first things first, I'll rewrite this. Okay, and then going here. Okay, all right, so going here, so it becomes 2x raised to 1/2 minus x raised to negative 1/2. So how did this happen? Okay, so basically I just divided this by this. That's why I got this. Okay, so uh, x divided by x raised to 1/2. So 1 minus 1/2. That's why you have 1/2 here. And then basically, to remove the fraction, so I just move it here in the numerator. That's why it has this negative 1/2 here. So that's it. So this is your new question. So we get the antiderivative of this. So basically that's simply 2, okay, from here. And then this is now 3 over 2 being 1/2 plus 1. And then over 3 over 2. Okay. And then minus same x raised to 1/2 being negative 1/2 plus 1. And then over 1/2. Okay. So going here, okay, let's simplify it here. So how do we get 4 over 3 here? So we basically, how do we divide fractions? So we have 3 over 2 here, so we get the reciprocal of that. So that's how. So 2 times 2 is 4 over 3. And then minus, basically this is 2x from the reciprocal of 1/2 here. Okay. So that's it. So we have now the antiderivative of the question itself. Okay. So we now find the limit from 1 to 4. Okay. So we have the expression, and then we plug in 4 for our upper limit minus. Okay. So this is for the lower limit. Okay. So we plug in 1. Okay. And then simplifying this, so we'll get 32 minus 4. Okay, you can simplify this right away with your calculators. Okay, so I just made this step by step. And then minus this one, so you get 4 over 3 minus 2. So answering this, okay, so you'll get 22 over 3 as your final answer. Okay, Sec 4, do you have any questions? Okay, none? All right, now let's have another example. Now let's have some word problems, okay? So again, you go to page 436. This is example number 10 in your book, okay? So you can just follow the question on your book, or maybe you just look here on your screen because it's basically the same, okay? Now, so for number 2, given that the derivative of a of x is equal to 2x minus 1, find the value of a of 3 minus a of 1. Okay, so if you observe the question here, class, so the derivative of function or a function is 2x minus 1, and then we need to find the value of uh, a sub 3 or a of 3 minus a of 1. So this is basically the upper, and this is the lower limit, right? Okay, so when you write your integration sign, so it starts from 1 until 3. and then you get the integral or the antiderivative of 2x minus 1. So given this derivative here, so we need to find the value of a of 3 minus a of 1. So I'll get the antiderivative of this first. Okay. So again, from 1 to 3, okay, being upper limit, and this is the lower limit. Okay. So how do we get the antiderivative of this? So it becomes 2x squared minus over 2 minus x. So simplifying that, this is the answer, okay, for the antiderivative of 2x minus 1. So we find out the upper and the lower limit, or up to the lower limit. Okay, so this expression here, we plug in 3 being our upper limit minus same expression but different value. So we have 1 being our lower limit. So simplifying this, our answer is 6. So that's it. Okay. So that's for your word problem number 2. Okay. Okay, so I took one question from exercise 20.2. Okay, will you please go to page 440. Okay, this is question number 7. Okay, on page 440. So given that the derivative of f of x is equal to root x minus 1, let's evaluate f of 4 minus f of 1. Okay, so again, 4 as your upper limit and then 1 as your lower limit. Okay, so how do you write this? So the antiderivative of uh, root of x minus 1 from 1 to 4. Okay. Okay, so what did I do first? So I rewrite uh, root of x here being x raised to 1 half minus 1 from 1 to 4. So getting the antiderivative of this, so it becomes 3 over 2 having 1 half plus 1. And then if this is 3 over 2, your denominator is also 3 over 2. Okay. And then minus x. So that the antiderivative of 1 is x. So simplifying this, so this is the answer for our antiderivative. Now we find the answer from our lower limit to the upper limit. Okay, so having this expression here, okay, um, we plug in 4 being our upper limit, okay, and then minus, same expression, different um, value. So we have 1 being our lower limit. So simplifying this, so our answer is 5 over 3. Okay, so Sec 4, do you have any question with example number 7? No question? Okay, so let's have our last example for today. Okay, so we go back to page 437. Okay, 437. Okay, so that's our last example for today. Okay, so let's have this. So I wrote here number 3, but in your book it's example number 11. Okay, so for example number 3, let me read the question. Given that y is equal to x minus 2 over x plus 1, show that the derivative of y is equal to 3x over 2 root of x plus 1. Hence, evaluate the antiderivative of x over uh, root of x plus 1 from 3 to 8. Okay, so that's it. So how do we answer this kind of question? Okay, now, first step here is we're given this value of y, uh, and then we need to get the derivative of this. We need to show that when you derive this, you'll get this answer right here. So we basically go back to differentiation here. So given this, y is equal to x minus 2 times x plus 1. So this is simply a product rule. Okay. So x minus 2 as the value of u, and then root of x plus 1 as the value of v. Okay, so this is the product rule, u dv plus v du. So u is x minus 2, so the derivative of u is simply 1. And then v is root of x plus 1, so the derivative of this is 1 over 2 root x plus 1. So that's it. Okay, so we now plug in these values into our formula here. So u is x minus 2 times the derivative of v, okay, plus v, which is root of x plus 1 times the derivative of u. So I didn't write that, okay, but there's that one there. Now simplifying this, so this one becomes this. So you just multiply x minus 2 by 1. Then you have this, and then plus x plus 1. Now, writing this as one fraction, so it becomes, this is your common denominator. So this divided by this is 1, right? 1 times x minus 2 is still x minus 2. Now, 2 root x plus 1, so this is over 1. So we divide it by 1, so we get the same thing, times root of x plus 1, okay? So multiplying this and this, so that cancels both of them. That's why you have just x plus 1 here, okay? Or simply it becomes root of x plus 1 squared, so it cancels out. So you're left with x plus 1, and simply you still have 2 here. So answering this is now your final answer. So we have proven that uh, y is equal to x minus 2 times root of x plus 1 will become 3x over 2 root of x plus 1. So this is the whole process, okay? So when you take your test, so the process is the whole score, okay, not the final answer, okay? Now, but we're not done yet. We need to evaluate this, okay? So this is the follow-up question, okay? All right, so evaluating this, okay, um, so we get the antiderivative of this first, right? Okay, so how do we write this? By the way, class, okay, so when you write this, so it becomes uh, x minus 2 and then root of x plus 1, right? Okay, from here, okay? So from here. Actually, uh, the question in the book is, so this should be 3x over 2, okay? Okay, so anyway, so let's answer this now. So we have x minus 2, so we just go back to our question here. Okay, so this one, right? So we have this x minus 2 times root of x plus 1, so because this is the reverse of this one, right? Okay, so our answer here, oh, don't forget, so I think I forgot something here. So there is 3 over 2 here, okay, from this. All right, so again, so this is the antiderivative. This is actually what's given. So we find the upper limit up to the, lower limit up to the upper limit, okay? So again, this expression here, So we plug in 8, okay, minus, okay, so for our next one, for the lower limit, so we plug in the value of 3. So therefore, your answer here, when you simplify this, this is 6 root of 9. So this is simply 18 minus, this is 1 times, this is root of 4, so this is 2. So this is 16, okay? So that's it. That's your answer, okay? So by the way, maybe you're wondering, okay? It should be 3 over 2, right? So the question is just this. So we just move, or we just factor out the coefficient 3 over 2, okay? Because it's not being asked also. So we just put that aside. So our answer here is 16, okay? Okay, now 16 for this now. Hence, our answer here, okay, as our final answer here is 32 over 3, okay? Just 32 over 3, okay? So that's your final answer for this, okay?